So it's not often we have someone who has full experience in the operator area and then comes over to the vendor side to talk about, in this case, 100 gig in the long haul and ultra long haul. Bill has over 35 years of experience in the telecom industry. He's was the vice chair of ADIS's OPTX OHI committee. He's also been active in the ITUT SG15, and prior to Xtera, this operating company experience, I'm going to go back to Sprint. He was a lot of years at Sprint, was in charge of the technology at Sprint. And after leaving Sprint, he went over to Xtera and was in charge of the optical networking there and was CTO for Monterey Networks. Once again, right now, he is CTO of terrestrial networks at Xtera Communications. Welcome, Bill.
I just like the way he introduces a 35 years experience. I want you guys to know I started when I was 2. Thank you, Rick. What I'd like to do is talk a little bit about the ultra high bit rate systems in the future. We talk a lot about 400 gig, talk a lot about 100 gig, and we talk about a lot of different alternatives. So what I would like to explore is there some other way that we can help to provide the capacity we need to carry the next generation of demand? So I hope by the end of this presentation, and you will know a little bit about the alternative that I would like to present, and talk a little bit about the amplifiers. And then I would also get into a little bit about the subsea network. And I think Rick already mentioned that my title really is involved with the terrestrial network, but the reason is I really didn't want to get my shoes wet too much, but I would also talk a little bit about the terrestrial network. Okay, somewhere is, okay. So I already mentioned about the option that we all want to have is to increase the capacity as well as the reach. The reach is important from the operator perspective because you certainly do not want to go back to the old day of 40 kilometer spacing with a lot of different HUDs. Rick mentioned the fact that back in the old days of Sprint, when we start doing WDMs, we have HUDs every 40 kilometers, and I was responsible for over 1,100 little buildings, 8-foot by 10-foot buildings. They're not cheap. You have to maintain the power systems and so on and so forth. We certainly don't want to go into that area again. And I would also want to cover a little bit about what the next generation of amplifier looks like. And, we're going to talk a little bit about 15 terabit. And then, like I said, we want to talk a little bit about the subsea applications. Okay. Again, we'll talk about a rapid increase of traffic demand. Some of you may already seen the IEEE study on the demand and a tremendous amount of data growth. And so we want to find a way to carry it. No doubt 400 gig is the solution, and I can assure you that Xtera is working very hard in looking into the 400 gig as well. But we also want to look at the possibility of other alternative before 400 gig or terabit is available. Okay. So in today's answer, we already covered a lot of it from the previous speakers. 100 gig system using the PMQPSK and with advanced FEC and so on. And trust me, I'm not going to go into it again, so make sure that even though I know you just came off a break, I don't want you to fall off your chair falling asleep. But the big issue here is that the 100 gig system today continue to follow the old tradition of tightly coupled line and client interface. Look back a little bit about SDH, about SONET, and so on. You're going to have a client-side interface of 100 gig, and you're going to have a line-side interface that are capable interface into 100 gig. In other words, that you have a 100 gig port working with 100 gig capable WDM system. That is a very tightly coupled system. Now, what would that happen? If you talk about going into 400 gig, for those of your operators, that means you're going to have to buy a 400 gig system that can work with a 400 gig interface. Well, that means you're going to spend a lot of money doing that. Now, for those system vendors, we love it. So, but on a technology perspective, what I see is actually a decoupling between the client-side interface and the line-side interface, allowing each of them to grow independently. Well, what are you talking about? Well, for example, we're talking about 400 gig E interface that IEEE is working on. Well, instead of having a line-side interface to have the capacity of 400 gig, what if I inverse multiplexing 4 100 gig wavelengths together to carry it? Now, somebody said, what's the difference? I already have 100 gig, but it really is not the same. You're just working in the 4 different 100 gigs. Now, a good example for that is if I have a piece of paper, one whole piece of paper, I can call that a 400 gig pipe. You can write on this paper a lot more than if I tear this paper into 4 parts, same size, but you can only do 100 gig on each of the portions. But if you inverse multiplexing 4 of them together, you will be able to carry a full 400 gig. Well, but what do I mean by growing independently? Well, a lot of people talk about terabit. I don't have to do 4 by 100. What if I do 10 by 100, 12 by 100, or to that end, maybe 2 by 100 or 3? So they're independent of the port you got on the client side, but is growing independently on the line side. Well, trust me, it's not easy to do, but on the concept basis, that is a good thing to look at. So, but one advantage of that is that you can reuse those 100 gig wavelengths you already own. You don't have to buy new ones. You don't have to build new huts. You don't have to do anything new. Granted, you have to change the amplifier. That's why we're going to talk a little bit about the amplifiers. Okay? So you may be able to save a little bit of money in transitioning from 100 gig to a higher capacity without buying all new things. And just one little example, I talked to a test equipment vendor the other day, and I asked him, I said, how much would a new test set be for 400 gig? He kind of looked at me, smiled, and he said, it will probably cost about $250,000 a piece. Okay, so if I have 100 technicians that need test equipment, how much would that be? He said, I'll love it. So it just tells you one of the costs of going to 400 gig, and maybe there is an alternative to use what you already have and still be able to meet the capacity requirements. Okay, I talk a lot about the decoupling of the two interfaces, but think about it. They have different reasons for growth. On the client-side interface, the requirement for growth is I want less ports instead of a lot of 10 gig ports or even 100 gig port. I want to have a single 400 gig ports. I want bigger pipes. And I want to have higher bit rate traffic. I want to be able to carry a 400 gig per bit per second traffic. It has a different reason for growth. But for the line-side interface, the reason for growth is I want to have more capacity. I want to be able to pass those traffic coming down to me, and I want to be able to carry it in a very effective way, a very low-cost way going forward. An important thing is I want to use the existing system. I already talked about it. But from a standard perspective, that they already separated. Now, some of you may be at the IEEE meeting last time, the first thing they mentioned is that the IEEE is responsible for the Ethernet interface on the client side. They are not responsible for the interface on the line side. The ITUT is, so they already decoupled from a standard perspective. So why don't we just take it a little bit further? Okay, so what are the options? Well, the option is that from an EDFA-based C-band system, the limitation is the bandwidth of the amplifier. It's not the number of channels, it's not a lot of other things, but how much you can do with the amplifiers. So the one way to increase the capacity is to increase the spectral efficiency. We have seen a presentation today saying, well, we'll go from 2 to 3 to 4, 5. Yes, it can be done. Technology allows us to do that. But trust me, it's not free. You may have to trade in the range. You may have to trade in other things in order to get that spectral efficiency increase. But I already mentioned earlier that range is important from a cost perspective. So is this a good way to do this? No doubt from a technology perspective, yes, it's a great way to do it. How long will it take? I don't know. Somebody mentioned about 2016. Somebody mentioned 2018. You're not even going to have standards probably around 2015. So, okay, that's wonderful. Well, we also talk about the super channel, about a Nyquist filter-based super channel, and so on and so forth. So all those are possible and can be done. So, but it means higher costs. It means more complexity. Well, trust me, it also means new test equipment. So what are the options? There's another dimension to this whole thing. The ITUT defined L-band and S-band on the same fiber. We are using the C-band now, but they define on 698.2, trust me, that L-band and S-band, there are two different bands that are contiguous bands and can be used. Now, I already mentioned the fact that you can't use, for example, the L-band because the limitation of the amplifier, the EDFA. So, with looking at all of this, so why don't we look at all those other things and see whether it would present a different alternative that may be easier to do and maybe we could use it until 400 gig or terabit is available. So I talk a little bit more about the amplifier. So what did it look like? Well, a lot of people say, well, okay, the advanced amplifier should have all of those characteristics. Low noise, transient suppression, on and on. So there are two kinds. There's a hybrid Raman EDFA, have the two units together. A lot of times they do use the EDFA as a preamp into the Raman amp. And the reason they do that is the EDFA tends to have a lower noise level, and with that amplify the signal into the Raman amp, it is very efficient. But then again, it limits you to the 8 terabit, the bandwidth the EDFA could work, or simply an all Raman amplifier. And they both have the advantage, they both have the disadvantage, and but depending on how you want to design your network, then you can apply that technology for your advantage. Okay, I'm going to show you a picture. This is a real-life design on a 19-span, 15 terabit system using the traditional single-mode fiber. And all this is a 100% Raman amplifier, and have 19 span, and it is going to be, it's not built yet, but it's going to be built very soon. And here's some of the simulations that we use to design this route. You probably tell me you can't see it. I would say, yes, you can, because I really don't want to show it to you. But that's not true. But then it's just the planning system that we use, and tell you that it is possible to do 19 spans of Raman amplifier close to several thousand kilometers, and you get up to 15 terabit. Now, I can tell you that this particular system can be expanded to 24 terabits using the same kind of amplifier. Okay, and this is some of the power spectrum and the noise, and hopefully that within a few months we'll have this up and running. So I'll talk a little bit about, we are only going to be using the L band at this point in time for the 15 terabit, but what are the advantage of doing that? Well, first of all, I mentioned that you don't have to buy new stuff other than, well, this particular route is an existing route. They already have EDFA on it, so they will have to buy new amplifiers and replacing that. And but you don't have to buy new 100 gigs. You don't have to buy other things. And then for those of us that have spent a lot of years in the carrier world, you hate that work about traffic grooming. You don't have to regroom traffic because you just use whatever you got. And you don't have to do rearrangements, moving them from one system to another and so on. And you will continue to use the 50 gigahertz spacing. No doubt, there is a way thinking now that what if I reduce the 50 gigahertz using Nyquist filter, and I will be able to increase that. From our simulation, we could increase around 30% or more on the number of channels. So I will have 30% more channels. Well, what that means is I can inverse multiplex more of those channels for bigger bandwidth. So yeah, I could use those technology. It's not here yet, but it will be here soon. And again, I could use the S-band to get up to 24 terabit. Nobody asked for that yet. And One of the common excuses that at least people told me was, oh, I'm not going to think about the S-band now because I'll be long retired before that happens. Well, that may be true. So, I mentioned about the compressed channels and so on, and but the important thing is, whatever you do today with the 100 gig you already own would not preclude you from going into 400 gig or terabit or other technology in the future. You already have it, you already pay for it. Well, instead of throwing it away tomorrow, you just extend the life of it a little further, but it doesn't stop you from doing something new in the future. So, we're done with the terrestrial, we're done with all those other things. Let's talk a little bit about the subsea. The subsea network is slightly different, and we've been able to use this optical gain module we call Roper to go further than what we normally can, and it's just not easy to pull it out of the water to add new amplifiers or whatever, or change the amplifiers. So it can be done and has been done. Okay. 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 Now, here's a, did I miss? No, I didn't miss it. Here's some of the announcements we have on 100 gig on the subsea. The one that I want to point out, one thing that is important if you look at this chart is the launch power we have in our system. Instead of we use 2.5 in here, we use 2.5 watts. The next example is 10.5. So we use 2.82 and 2.92. The other example is 6.3. So the launch power is greatly reduced, it's more efficient, and those are actual announcements that we made at the various different conferences, and they are working today. The 100 gig system is working today. So yes, they are available, they're working. And we have system actually working all the way across the Atlantic. And so those 100 gig system working in the subsea world today. Okay? Now, if you like to have more information, our sales department is sitting right there, and I'm sure he would love to answer your questions, right? And here's one of the examples that I would like to show you, that about 100 gig submarine and backhaul, this is both a terrestrial network and a submarine cable working close by here, that 8,000 kilometers, 100 gig optical routes. And again, it is working, is in service, is carrying live traffic, and is not a hero experiment. Okay, a little bit more detail on this route. And again, I'm sure our sales department will be glad to explain that to you in more details. And the important thing is that this is a first 100 gig repeated cable system in commercial service. It's been in service since Q1 2012. It is a repeated 100 gig system. Okay? And have a backhaul network, which is the terrestrial part, in the based on leased fiber, have different fiber type. Now, you thought that you want to drive your network planning and engineering folks crazy. Just give them that configuration and say, oh, it's 4 different fiber type. I'm sure they love you. And have working and protect route and with the optical line protection. And then it's the same platform we use for 100 gig technology for both the land and the subsea part of the network. I think Rick asked a question earlier about using the same technology for metro and long haul. He's the same technology for subsea and terrestrial. Again, I'm only thinking about that test equipment sales guy. So in the summary, that 100 gig technology, we've been deploying them since 2011, and we're the first to deploy soft decision facts. We're on 40 nanometer CMOS now, going into 28. And so no doubt that we could improve the technology, improve the economy of employing the system, and 15 terabit line capacity system is available today. I'm not so sure we could ship tomorrow, but I'll try. And we do have the optical amplification system that is available, but most important, I would like all of you to think about the possibility of decoupling the line-side interface to the client-side interface and allowing better growth for the future ultra-high bit rate system. With that, I'll shut up and I'll ask questions.
So we have time for a burning question. Yes, Hans Martin.
I figured it has to be Hans.
Sorry about this. Bill, you are challenging my pure geographic knowledge. Between Egypt and Italy, where are these 8,000 kilometers coming from? It must be much less.
Okay.
Correct that. That's the GDI network that goes south.
Okay.
Not that the point is shows 2,000.
Okay, thank you.
There's a good reason you take the sales department along.
Good.
Thanks,
I'm glad we've got our geography straight
Yeah.
now. Excellent. Okay, thank you.
Thank you.
Now we're going to address leveraging new network capability to improve service economics. Oh, improve economics, yes. Okay. This is Per Larson, Executive Network Architect at TDC. He joined TDC in 2001 and currently holds a position of Executive Network Architect for Capacity and Planning Department with focus on optical transmission, mainly DWDM and SDH networks. He's worked in carrier networks from the mid-'80s. We won't say his age, but you started at 5, right?
3.
Yeah, okay. He's worked with X25, frame relay, and ATM in planning, building network operation were the main topics he's been working with. He's gained experience at Szeto, Enator,
Yes.
Telecom Finland, Xtera, Tele1 Europe, and Song Networks. That's a good team. I like that. Okay. Since 1997, he's focused on optical transmission platforms, primarily, once again, DWDM and SDH. Today, he's very active in the development and planning of TDC's optical transmission networks in the Scandinavian and European region.
Thank you, Rick, for that presentation. It was very detailed. Good. Yes, I have an opportunity